Hello everyone, Mr. Schultz here as we dive into inverse relations and functions. Our learning objective for today is to be able to evaluate two relations and determine if they are inverses. Now, what does this mean? Well, we have inverse relations in which we have one group have a bunch of coordinate points like 1 comma 2, and then it has 3 comma 4, and then we have like 5 comma 10. The inverse relations to that would be switching out the coordinate points. So instead of 1 comma 2, we now have 2 comma 1. Instead of 3 comma 4, it is now 4 comma 3. And finally 10 comma 5. Now, if we're going to use letters, we could say A comma B. And what would that turn into? The inverse of that would be B comma A. All right. So what does that mean? Well, inverse functions. So if we had a function, let's say f and g, and those would only be inverse functions if and only if both of their compositions are identity functions. Wait a second, what does that mean? Well, that's when we were putting one function into the other function. So if I have f of g of x, if we plugged one into the other one, then we should get x. The identity function is y equals x. So this would be equal to x. And it's saying, hey, if we plugged f of x into g of x, what would the answer be? Well, they're saying, hey, if we plug it in, it should be y equals x again, or g of f of x is equal to x. Well, why don't we come back to this? Let's talk about some given points, quick and easy. So if we have the function, here's function f, right here, function f. The inverse will often have this like -1 right here. This is the inverse of function f. Notice how we have the points 1, 2, 3, 4. Our inputs will give us an output. Whereas in f, the inverse of f, our inputs give us our outputs. Yes. No matter what, we have our input and our output, but it's the numbers change. So if we plugged in 1, we get A. And if we plugged in A, we'll get 1 for the inverse of function f. So basically, we're going to go from this to this. This is f, and this is the inverse of f. All right, let's go on. So let's do a quick and easy test right now. Let's prove these are inverses. So the input of one will be the output of the other one. So f of 7 will equal 7 minus 5 if f of x equals x minus 5. Well, we see that f of 7 is equal to 2. So if we plug this into what we think is our inverse, we should get the input of 7 as our output. So now I'm going to input this into our inverse. So it's saying, hey, I want you to plug 2 into the inverse. And we get 7. Hey. So instead of 7 comma 2, so f has this point right here, the inverse has this point, 2 comma 7. So basically, we're just switching the x and the y. So the quick and dirty of it, we look and see, hey, are these switched? Then they're inverses. Are they functions? Well, only one way to tell. We're going to put one into the other. So we're going to put f, the inverse of f, into the function of f. So why don't we do that? So it's going to be this x. We're going to input our input into this something minus 5. Well, the something we're going to put in is x plus 5. And now we have this minus 5 right here, and that's x. So this guy, the composition of f of the inverse of x, we get x. And this is our identity equation right there. Well, let's test the other one. So we're going to input the function f into the inverse of f to prove that it is an inverse. So we get plus 5. We're going to switch out our input for our new input, x minus 5. And when we simplify this, we get the same result. The identity equation, or y equals x. And so we need to know how to compose functions right here so that we can do a quick test and see, hey, are these inverse functions? That's it. All right, guys. See you in class. Have a good one. Bye.